first one, Biot-Savart Law. Now, what is the purpose of Biot-Savart Law? To find magnetic field. So, Biot-Savart Law gives magnetic field due to the small element of current carrying conductor. Now you take current carrying curved conductor. Now you take one curved conductor. Now what is the specialty of curved conductor? In this case, the current is not symmetry. There will be fluctuation in the electric current with time. So this is AB is a curved conductor. Now this curved conductor is divided into number of equal parts. One of the small part is called element. Here AB is what? A small element. The length of this element is dl. Here the current passing through this conductor is I. The same amount of current is also passing through this small element. It is very small, very near at these two ends. For the sake of convenience, I am taking at larger distance. So when current is passing through this small element, now we find magnetic induction at any one point nearby this conductor. Let us choose. So we want to find the magnetic field at the point P. Here the magnetic field is only because of electric current. So here the magnetic field is directly proportional to strength of the electric current in the small element. If the strength of the current increases, magnetic field is also increases. If the strength of the current decreases, magnetic field is also decreases. Hence we can write magnetic field due to the small element directly proportional to strength of the electric current. And it is also directly proportional to length of the element. It is also proportional to length of the small element. It depends upon both. I into dl is called current element. Now you take this point. If you take this point P, very infinite distance, what happens? The field becomes zero. If this point P we take very nearby the conductor, the field becomes infinity. So that means here the field is also depends upon the distance of this point from the conductor, from the element, from the source. So that is why we connect the point P and this element. And now we connect this edge or this edge. These are two very narrow. But we are taking the larger scale. So here R is equal to what? The distance of this point from the source or position vector. The angle between them, theta. So here the magnetic field is also directly proportional to the side angle between element and the point. dB proportional to sine theta. So here magnetic, according to Biot-Savart, the magnetic induction due to the curved conductor, it depends upon these three factors. On those three factors, it directly proportional. Out of them, which is increases, the magnetic field will increases. Here depends upon sine angle. So if both are mutually perpendicular, the small element and the position vector, then what happens? The magnetic field becomes maximum. If theta is equal to 90 degrees, dB becomes maximum. Now, it is also depends upon the distance. So, if the point P, if we bring very nearer to the conductor, the field becomes infinity. If you take infinity distance, the field becomes zero. So, that is why here the field, magnetic field due to curved conductor is also depends upon distance, square of the distance. It is inversely proportional to square of the distance. Same Coulomb's law. It is follows Coulomb's law. So totally, according to Biot-Savart law, this is an experimental result. Depends upon these four factors. dB proportional to ideal sin theta by r square. Now, so far there are four factors. So another factor is there which influence here the magnetic field. The another invisible factor. Now you take coronavirus, how it will affect our biological system? In the same manner, here another invisible quantity, which is also influence here existing magnetic field. That is the property of the medium. Here the property of the medium is also relatively either decreasing or decreasing existing magnetic field. That is why we must take into consider the property of the medium. Here the medium is either air or vacuum, both are equal. Here the property of this medium is called magnetic permeability. It is always constant, wherever, in all places, the magnetic permeability of free space and air is constant. We are taking this constant in the form of proportionality constant. It is in our physics culture, whenever this proportional symbol is removed, then we can write one proportional constant. Here what is that proportional constant? dB is equal mu naught by 4 pi ideal sin theta by r square. Here mu naught is equal magnetic permeability. What is mu naught? Magnetic permeability of free space. Its value is constant. Mu naught value is 4 pi into 10 to the power of minus 7 Henry per meter. Now you know Newton universal gravitational constant. F is equal in gravitation law. Here, whereas Newton gravitational constant does not depend upon intervening medium, but whereas here field depends upon the medium, in which medium the conductor is present. It depends upon the nature of the medium. But here it does not depend upon nature of the medium. So mu naught by 4 pi ideal sin theta by r square. So this is called Biot-Savart law, scalar form. So magnetic induction due to curved conductor. If you want to express in the vector form, the given equation is multiplied with unit vector. dB is equal mu naught by 4 pi ideal sin theta unit vector. We have unit vector. How can we write? The vector n by its magnitude. Vector n means r into by now instead of unit vector, now we substitute this value. dB becomes mu naught by 4 pi ideal sin theta by r square instead of unit vector. Ideal sin theta cancel. So we have dB is equal mu naught by 4 pi. So this is current element by r square into r cube. So this is scalar form of Biot-Savart law. Scalar form of Biot-Savart law. To find magnetic field due to the small element of curved conductor, then we can use this formula. And I have Biot-Savart law and the Coulomb inverse square law in electrostatics. There is some similarities. Coulomb inverse square law in electrostatics. 1 by 4 pi epsilon naught Q1 Q2 by d square. Both are inverse square laws. Biot-Savart law in magnetic field, in electric field, electrostatic force. Both are inverse square laws. Whereas here magnetic field is depends upon current element, whereas electric field is depends upon the scalar quantity electric charge. So electric field is because of the source is scalar quantity. Here magnetic field source is vector quantity, current element. Here electric field, magnetic field are having same properties. The field lines are different. You know, in the case of electric field, you never expect closed loops. But only in the case of magnetic field, we can expect closed loops. So thank you. In the next class, I am going to teach Ampere's law.